Assalamualaikum everyone. In today's video, we will be discussing Brownian's motion. So, what is Brownian's motion? Firstly, you need to know the definition of this Brownian's motion. So, Brownian motion is the random motion of the tiny particles suspended in a fluid. So, this is the motion of the fluid. So, let me write the definition here. That the random motion random, of tiny particles in fluid is is known as the Brownian motion. Now, the next thing in this motion is that it is caused by the continued uneven broadening of fast moving gas or liquid molecules or the tiny particles of on different sides. So, this is a motion caused in the liquids and gases, and it is caused due to the uneven broadening of fast moving gas molecules. So, caused by the continued uneven broadening of fast moving particles. Fast moving gas or liquid particles. You can say molecules instead of using the word particles on the different sides. So this was the second point of this Brownian motion. Then the third point is that this result in the tiny particles moving in an erratic and random motion in all directions. So this results the movement of particles in all directions. So let me repeat this Brownian motion once again. That Brownian motion is the random movement or the random motion of the tiny particles suspended in a fluid. Brownian motion is caused by the continued uneven broadening of fast moving gas or liquid molecules of tiny particles on different sides. This results in the tiny particles moving in all the directions in random motion. So this was the total definition of the Brownian motion. I hope you understood it. Let's move towards the second part, which is the gas particles. So gas particles cause the pressure caused by the gas particles or the gas molecules. We will discuss this. Let me write it. So gas particles, they are always in a continuous motion, and there are numerous collisions between the gas molecules and the walls of the container. So this exerts the force and the pressure on the walls of the container. Then the next thing we need to discuss is the pressure caused by gas and the relationship of pressure and temperature and pressure and volume. So pressure is directly proportional to temperature. As the pressure increases, the temperature also increases. For this, pressure divided by temperature equals to constant. So how we form this formula of pressure divided by temperature? When this inverse proportional sign is removed, equals to sign comes here, and the t shifts towards the left side. And here the constant, which is k, or you can say the constant simply. So this t comes here and divides by the pressure, and there is the constant k or constant. So by this we derive this formula P1 divided by T1 equals to P2 divided by T2, means This initial pressure divided by initial temperature equals to final pressure divided by final temperature. When the temperature increases, the kinetic energy increases. The kinetic energy of the gas molecules increases. This causes them to move faster as their speed increases, or you can say their velocity increases, and they collide more frequently with the walls of the container. As a result, the pressure also increases. So let me write it here that the kinetic energy increases, then, or you can say the kinetic energy is directly proportional to temperature, which is directly proportional to the speed. And this speed, or you can say the movement of molecule, the faster movement of the molecule is directly proportional to the frequent collisions. So these all kinetic energy, temperature, speed, and frequent collisions all are directly proportional when they increases. When the kinetic energy increases, temperature also increases, speed of the molecules increases, they move more fast, and the frequent collision rate also increases. Secondly, you need to know the relationship between pressure and volume and temperature. So volume and temperature are directly proportional. When the volume increases, the temperature increases. Volume of a gas is directly proportional to the temperature at the constant pressure. Thus, the pressure should remain constant. So here we come up with the formula V1 T1 equals to V2 T2. So we came up with this formula by this. Then when this proportionality sign is removed, equals to come here. This T which is at the left, here is a constant with T, and here is V1, T1, and this is constant K. When this T is dividing with multiplying with K, when it comes towards left, it divide with K. So V1 divided by T1 equals to K. So here is the constant. By this we derive this formula V1 T1 equals to V2 T2. Then let's move towards the next thing in this chapter. So when the temperature is increased, the gas particles gain kinetic energy and start to move fastly, or start to move in fast speed as the temperature increases. As a result, they overcome their intermolecular forces of attraction and move further apart or further away from each other. This causes the volume of the system to increase. So this is how the volume increases. Now the third relationship you need to remember is the of pressure and volume. So pressure is inversely proportional to volume, means when pressure increases, the volume decreases, and when the volume increases, the pressure decreases. So the graph for the inverse relationship is like this. It looks like this. So here is a formula P1 V1 equals to P2 V2. We derive this formula like this, that when this inverse proportionality sign is removed, equals to come here, K is the constant and V is here. So this P into V equals to K, and this K is constant. So we came up with this formula P1 V1 equals to P2 V2. So I hope you understood it. Thank you.